There are three key equations you need to know for kinematics in AP Physics. We looked at the first one already. It's VF equals VI plus AT. There's two more. Let me write them down right now. The second one is D equals VIT plus 1/2 AT squared. And there's a third one, VF squared equals VI squared plus 2AD. So we're going to spend a little time thinking about these and getting comfortable with them. But I recommend that you write them down. I even recommend that you take a moment to pause the video and write them down. The act of writing them down will help you feel more comfortable and familiar with them. So pause the video right now and write them down. Okay, let's do some examples for each of these equations and think about them. Let's start with this one here. Let's imagine there's a race car at the starting line of a race. The light has just turned green and the driver hits the gas and accelerates the car. Let's say he accelerates the car at 14 meters per second squared. The driver accelerates like this for 6 seconds. The question is, how far will the car go after 6 seconds in this time of accelerating? Now, we have three variables that's been given to us. We have the initial velocity, acceleration, and the time. So we're looking for the distance. So one of the tricks in kinematics is choosing the correct equation. In this case, if I tried to use the first equation that we looked at, it would be wrong. It's not going to give me the right answer. For one thing, distance is not inside this equation. For another thing, I don't have VF. Instead, I'm going to use the second equation here, D equals VIT plus 1/2 AT squared. So let's write out what we have so we can kind of think about it systematically. The initial velocity is 0 and the time is 6 seconds. And the car is accelerating. It's going at 14 meters per second squared. So I just need to take these variables and plug them in to that formula. Let's do it. So I get D is 0 times 6 plus 1/2 times 14 times 6 squared. So this term here is just going to be 0. So I just need to plug that into the calculator. So my final answer is 252 meters. Great. So this car is going to travel 250 meters as it's accelerating. Now the initial velocity is 0. We don't know what the final velocity is from this problem. We could calculate that perhaps, but we don't need to know it. The fastest way for you to improve your grades is to do a practice test. On my site is a free kinematics practice test. Click the link below to get yours today. Let's imagine there's a person standing on the top of a cliff and they throw a ball downwards. The cliff is 20 meters high and when they throw it, it reaches the bottom of the cliff in 0.8 seconds. The question is, what was the initial velocity that this person threw the ball downwards with? Let's write down the variables that we have and then use the same formula here. The distance the ball travels is 20 meters. The time is 0.8 seconds. The acceleration is the acceleration due to gravity, and we can write that as 10 meters per second squared. We're looking for VI. So I'm going to take all these numbers and put them in the equation, this one here. Okay, so we just need to do a little bit of calculation. First of all, I need to figure out what all this term is together. So that term is like 3.2. So I need to now subtract that on the other side to isolate for VI. I get 16.8 equals 0.8 VI. I just need to divide by 0.8 on both sides. I get that the initial velocity is 21 meters per second. Okay, very good. So in this question, I had a bunch of variables, the distance, the time, and it didn't tell me what the acceleration was. So very often I'm going to have to think about what's acceleration, and often it's going to be g when things are going down or upwards as well. And the question is saying, if this is how long it took to go down the bottom with the acceleration, then the initial velocity must have been 21 meters per second. Let's do some examples about this second equation here. Now, it's again a similar equation with some variables, but it's also unique. Vf squared equals Vi squared plus 2AD. It's not quite the same as the other ones. So let's imagine this same situation here. Let's say that guy has a ball and he throws it down the same cliff, and this time he throws it down with an initial velocity of 15 meters per second. The question is, what will be the velocity when it hits the bottom of the cliff down there? So we're asking about the moment just before it hits the ground. What's the traveling speed? I'm not worrying about after it stops. I want to know what the final velocity is, the fastest that it's going in the whole process. So let's write down the variables that we have. The question says that the initial velocity is 50 meters per second and the distance is 20 meters. We can take the acceleration as the acceleration due to gravity. That's 10 meters per second squared. What we're looking for is the final velocity. So I'm going to put my variables into that third equation and see what happens. I get Vf squared equals 15 squared plus 2 times 10 plus 20. So we do all that math and we get 225 plus 400. So Vf squared equals 625. So I just need to take a square root on each side. Very convenient. This one's actually exactly 25 meters per second. So the ball is thrown with 15 meters per second and it gains some velocity because of the acceleration due to gravity. At the end, it's traveling faster. It's traveling at 25 meters per second. Okay, here are the three kinematics equations. If you get comfortable with these, you'll be comfortable with kinematics. Awesome. Do you have any questions about this? Type in the comments below any question that you have left.